right, so in section 1 of chapter 6, we're talking about simplifying radical expressions. Well, what do we mean by a radical expression? Is anything that contains the square root sign. And before we can talk about simplifying radical expressions, let's talk about perfect squares. Well, a perfect square is any number whose square root is a rational number. We're going to be talking about that more specifically a little bit later on. But just off the top of your head, you should know what at least the first 15 perfect squares are, which are 1, because the square root of 1 is 1, and the square root of 4 is 2, the square root of 9 is 3, and so on down the line. The square root of 16 is 4, the square root of 25 is 5. When you take the square root of 36, you're going to get 6. When you take the square root of 49, you get 7. The square root of 64 would be 8, and 81 would be 9, and the square root of 100 is 10. And you probably knew those way back by, what, 3rd grade or 4th grade or something like that, maybe? The square root of 121 is 11. The square root of 144 is 12. Anytime you see the square root of 169, you should know that that's 13, and that the square root of 196 is 14. And look at these two numbers, 169 and 196. You should know that those two numbers right off the top of your head, because look at the numbers. They're reversed. 169, 196. You get 13 and 14. Radical 225 is 15. It's a nice round number. 225 you should know is the radical of 225 is 15. You should also note too that any variable raised to an even exponent is a perfect square. Now let's look at some examples. The square root of x squared is x. And let's see now, the square root of a to the 10th is a to the 5th. How about we look at the square root of b to the 14th? Well, the square root of b to the 14th is b to the 7th. And let's see now, the square root of what? C to the 20th would be c to the 10th. Now, what's the rule? I've given you 4 examples here. What's the rule? That's right, you take half of the exponent, or divide the exponent by 2. That will give you the square root in terms of that variable. And let's look at this too. We're talking about simplifying radical expressions, so when do we know a radical expression is simplified? Well, the first thing you're always going to look for is to make sure that no factor under the radical, now the number underneath the radical is called the radicand. There's another new word for you probably. No factor under the radical can be a perfect square. The second thing we're going to look at, and we'll talk about this later, but the second bullet here, here's the first. The second bullet is going to be the fact that you cannot have a fraction underneath the radical. Meaning no radicand can be a fraction. You can't end with an answer looking like that. And we also cannot have there can be no radical in the denominator. We'll talk about that one a little bit more detail later on. Let's look at number 1. Now 12 itself is not a perfect square, but there is a factor of 12 that is a perfect square. What factor of 12 is a perfect square? It's 4. So what we could do here is break the 12 down into radical 4 times 3. And what is the square root of 4? Well, it's 2, so we would have 2 radical 3 as your answer. 72 has several different factors that are perfect squares. 4 can go into 72, 9 goes into 72. We always want to find the largest though. And the largest number that can go into 72 that is a perfect square is 36. So I can break 72 down into radical 36 times 2. And that will break down to radical 36 times radical 2. The square root of 36 we've said is 6, so our answer would be 6 radical 2. Now, square root of 400, well, it is a perfect square. The square root of 400 is 20. You should know that one off the top of your head. Now, let's say you don't know what the prime factor, or excuse me, any perfect squares that multiply together to get 18. Let's say we can't see that right away. I mean, what I'm seeing is radical 9 times 2, and the square root of 9 is 3, and I get 3 radical 2. But let's say we don't see that right away. There's another way we can find how to break down 18, and that's by finding the prime factors. So what I'm going to do, I'm going to take 18, and I'm going to put a box underneath it like so. And I'm going to take 18, and I'm going to start dividing by 2. Because 2 is a prime number. Now, 18 divided by 2 is 9, and I'm going to put that underneath. And here's how I find prime factors of any given number. So the prime factors of 18 are 2 times 3 times 3. And then what I'm going to do is look for any pairs of factors that, what pairs of factors that are the same. And I have a pair of 3s. That means I can bring one out in front. The 2 is left behind, so I have 3 radical 2. That's another way we can do these. If you don't see 25 can go into 75, find the prime factors of 75. I can divide that by 3, I get 25, divide that by 5, and get 5. So radical 75 is radical 3 times 5 times 5. Now anything that has a match to it, any pairs that are the same, I can cross those out, and I'm going to bring it down outside the radical. So I'm going to have a 5 outside the radical. And then the 3 doesn't have a partner, so it stays inside. So I'm going to have 5 radical 3. In number 6, if you see a perfect square, take the square root of it. 9 is a perfect square. What's its square root? 3. What's the square root of x to the 4th? Well, we found out earlier that all we have to do is divide the exponent by 2, so I get x squared. So the answer here would be 3x squared. Number 7. Now, check this out. I've got 300 into the 5th. And how do I handle the end of the 5th? Because it's an odd. I can't divide 5 by 2. I get 2.5, and we can't have that as an exponent either. So what do I do? Well, I'm going to take 300. Let's look at 300. And I'm going to divide it by 2 and get 150. I'm going to divide that by 2 and get 75. And I'm going to divide that by 3 and get 25. Divide that by 5 and get 5. So here's 300 broken down into prime factors. 2 times 2 times 3 times 5 times 5. Now, if I can't take into the 5th and divide the 5 by 2 evenly, I'm going to break it up so that I can do n to the 4th, but I need another n to get my n to the 5th. So I have n to the 4th times n. Well, how do I find this? I'm going to pull out a 2. The 3 stays because it doesn't have a partner. The 5 gets to come out. The square root of n to the 4th is n squared. The n stays behind here, so I have radical 3n. And now I just simplify everything by multiplying the numbers that are outside, the coefficients, 2 times 5, 10, n squared radical 3n. 128, c to the 6th, d to the 3rd. Well, I'm going to take 128 and find the prime factors. I'm going to divide by 2 and get 64. I'm going to keep dividing by 2 as long as I can. Get divided by 2 again, I get 16. Divided by 2, I get 8. Divided by 2, I get 4. Divided by 2, I get 2. So I have 1, 2, 3, 4, 5, 6, 7 2's I want to write down. Now, c to the sixth, I can find the square root of that easily. D to the third, I can't. I'm going to break that down into d squared times d. And now I'm going to go through and find my square roots by pulling out the same factors. Here I have a 2. Here I have another 2 that's in common, and another 2 yet. This 2 doesn't have a partner, so I'm going to circle it. I'm going to come back to that later. C to the sixth, I get c to the third. D squared, I'm going to get d. This one stays behind, so I'm going to have radical 2d that stays behind. 2 times 2 is 4 times 2 is 8. 8c to the third d, radical 2d is my answer. In number 9, 20. I'm going to take 20, divided by 2, you get 10. Divided by 2, you get 5. So I'm going to have 2 times 2 times 5. I'm going to have x to the 10th times x times y to the 6th. I can take half of that times z. Now, the 2 times 2, we get to bring out a 2. The 5 stays behind. It doesn't have a partner. X to the 10th becomes x to the 5th. The x will stay behind. Y to the 6th becomes y to the 3rd when I take the square root of it. And the z stays behind. So inside the radical, I'm going to have 5xz. So my answer is 2x to the 5th, y to the 3rd, radical 5xz. In the next page, number 10, if you can see that we have radical 4 times 10 would be your radical 40, which makes it radical 4, I don't want to do 2 yet, radical 4 times radical 10, and the square root of 4 is 2. There's your 2, and you get radical 10. So 2 radical 10 is your answer. If you can see the largest factor that's a perfect square, go ahead and do it that way. Otherwise, find your prime factors. Either way is fine. In number 11, we have radical 7 over 16. And if you recall, we cannot have a fraction underneath the radical sign. So what do we do here? Well, my old algebra teacher, my freshman algebra teacher, Jim Myers, always told me the square root of the whole thing is equal to the square root of the parts. So I could take the square root of 7 in the numerator and the square root of 16 in the denominator, and I know what the square root of 16 is. I can't simplify the square root of 7, so I leave it radical 7 in the numerator. The square root of 16 in the denominator is 4, so your answer is radical 7 over 4. In number 12, I'm going to break this up into radical 204 over radical 25. And in the denominator, I'm going to have 5. Well, what's in the numerator? Well, I'm going to take 204. I'm not saying real quickly what the largest perfect square is. So I'm going to find the prime factors. I'm going to divide it by 2, get 102. Divide that by 2, get 51. Divide that by 3, and I get 17. So radical 204 is radical 2 times 2 times 3 times 17. Well, I get to pull out this 2. I get 2. These guys don't have partners, so I'm going to multiply them back together again. 51 over 5 would be your final answer. In number 13, the square root of 1 is 1. The square root of 36x squared is 6x, but now keep in mind where they are in terms of the fraction. The 1 is in the numerator, the 36x squared is in the denominator, so when you take the square root of it, it will be in the denominator, so 1 over 6x is your answer. In number 14, when I look at a fraction, the first thing that I see that I am going to want to do is to reduce that fraction to lowest terms. And I'm going to do that here. Now, up here, number 11, we can't reduce the 7/16, so I didn't bother there. 204, in number 12, 204 over 25, we can't reduce that fraction, so I didn't bother there. But in number 14, I can reduce this fraction. 72 over 4 is 18. So I'm going to have radical 18, and then x to the 7th over x to the 4th is x to the 3rd. This is what we need to simplify, not this messy looking fraction. So 18, I get 2 times 3 times 3 times x squared times x, because remember we can't take half of x to the 3rd, so I'm going to be able to take half of x squared, or half of the exponent anyway. I'll bring out my 3. I have an x that I'm going to be able to pull out. This 2 stays behind, and this x stays behind, so 3x radical 2x is my answer. In number 15, I get radical y over radical x squared. In the numerator, it remains radical y. In the denominator, I get x, so radical y over x. And in number 16, we have radical 3 squared plus 4 squared. Now, I want you to write this down, the fact that radical signs are a form of groupings. What do I mean by that? Well, in your order of operations, remember you're supposed to do parentheses, exponents, multiply and divide, add and subtract, right? Well, it's not just parentheses. It's all kinds of groupings, and there are several different kinds of groupings in math. There are parentheses, obviously. We've got parentheses, braces, brackets, fraction bars, absolute value signs, and radical signs, which means anything that can be computed underneath a radical sign, we need to do that. Well, let's compute 3 squared. We get 9. Plus, compute 4 squared, 16. We have to add that together first, so we get the square root of 25, which is 5. There's your answer. In number 17, this is a little bit different because we can't actually compute x plus 4 because x is a variable. So this is going to be handled a little bit differently. Suffice it to say that the squared sign here cancels out any square root sign, and you're left with x plus 4. In number 18, try to reduce 15 over 16. It cannot be done, so you break it up into its two parts. Radical 15 over radical 64. We have radical 15 in the numerator, 8 in the denominator. Number 19, radical 63. Now, remember to bring down the 3x that we have in the first place. And radical 63 is going to be radical 9 times 7. Continue to bring down this 3x that's in front. The square root of 9 is 3, so that's times 3, and we have a radical 7 left over. Well, we can't leave the answer like this. We have to multiply this 3 times this 3, and we get 9. So our answer is 9x radical 7. In number 20, we try to reduce the fraction first. We can, not the 7 and the 81 so much. They remain. But x to the 4th over x to the 3rd is x in the numerator. Now, we can't reduce this fraction anymore, so we're going to break it up into its two parts, radical 7x over radical 81. The square root of 81 is 9, so we end up with radical 7x over 9. And then 500 is 100 times 5. I'm not going to do prime factors on this one. I know that 100 is an easy number to remember, and it goes into 500 easily. So we have 100 times 5 times x squared times y to the 4th. The square root of 100 is 10. The square root of x squared is x. The square root of y to the 4th is y squared. This 5 stays behind, so the answer here is 10. X, y squared, radical 5. Continuing on to the next page, the square root of 121 is 11. The square root of 36 is 6. The square root of 1 is 1. In number 4, don't forget the 6 that we have in front of the radical. That means 6 times radical 225. And again, the square root of 225 is 15. So 6 times 15 is 90. Some of these you might be able to remember because you're going to see them over and over again. So the radical 20 would be radical 4 times 5. If you can remember 2 radical 5, do that. In number 6, we have radical 12. This is going to be 4 times radical 12. And radical 12 would be radical 4 times 3. So we have the 4 that's in front. We get to bring out a 2. That would be 4 times 2. We have the radical 3 left over. 8 radical 3 would be your answer. Number 7, radical 15 over 16. The 15 sixteenths cannot be reduced, or we break it up. Radical 15 over radical 16, which is radical 15 over 4. In number 8, I cannot reduce the 5 over 81, but I can reduce the x to the 4th over x to the 3rd. So I have 5x over 81. Break it up into its 2 parts. And we are left with radical 5x over 9. Number 5, we have the 5 that is the coefficient in front of the radical. We have the square root of 36. 5 times 6 is 30. And in the last set of problems, 45, x to the 4th, y to the 5th. Well, I'm going to break the 45 up into 9 times 5. Why? Because 9 is a perfect square. I'm going to write down x to the 4th. I'm going to take one of these y's away and write it y to the 4th times y. The reason why I'm doing that is so that I make an even exponent that I can divide by 2. All right, so what are all these simplified? Well, the square root of 9 is 3. The 5 stays behind. The square root of x to the 4th is x squared. The square root of y 4th is y squared. The y stays behind, so we have 3x squared y squared, radical 5y. In number 11, I'm going to rewrite this as 9 times 10, x squared times x. The square root of 9 is 3. The square root of x squared is x, radical 10x. And in number 12, I have my 3 that's outside. I'm going to have on the inside radical 9 times 2 times x times y squared times y. Again, I need even exponents. So what do I have here? Putting it all together, I have the 3 that's outside. The square root of 9 is 3. The 2 stays, the x stays. The square root of y squared is y. This y stays, so I have inside 2xy. Final answer, 9y radical 2xy. Well, that does it for simplifying radical expressions as far as the first couple of steps go. We will discuss more in the future. Until then, have a great day.